You know that number, 1/3? We all learn in school that it's 0.33333333, just repeating forever. But have you ever stopped to think how weird that is? How can a number that never, ever ends be an exact value? Well, today we're pulling back the curtain on this little piece of math magic. It looks like a trick, but I promise it's pure, elegant logic. So let's just get right to it. The big question. Is 0.333 repeating exactly the same thing as the fraction 1/3? I mean, it's so easy to think of that decimal as just getting closer and closer and closer, but always falling just a tiny bit short. Is that actually true? And that's the whole puzzle, isn't it? It feels like one of those trick questions, but this is not a case of close enough. Today, I'm going to show you in two totally different ways why these are precisely the same value. It's one of my favorite bits of math magic. Okay, first up, let's get into the pure, undeniable logic of algebra. This is the kind of clean proof that leaves absolutely no room for doubt. So, how in the world do you work with a number that goes on forever? You can't just punch it into a calculator. Well, here's a classic move. You just give it a name. Let's call our repeating decimal x. Simple enough. From now on, x equals 0.333. All right, with our problem set up, x equals 0.333 repeating, we can make our first move. We're just going to multiply both sides of that equation by 3. So on the left side, x becomes 3x. But what happens on the right side? What do you get when you triple 0.333? Well, you get this, 0.999 repeating forever. So now our equation is 3x equals 0.999. And I can hear you thinking, great, you just swapped one weird repeating decimal for another. But trust me, this step right here is the key to the entire puzzle. And here is the secret that unlocks everything. Now, this might feel a little strange, but it's a fundamental truth in math. The number 0.999 repeating isn't just really, really close to 1, it is 1. They're the exact same value. There's no tiny gap between them. They're just two different ways of writing the same number. Once you accept that, the whole problem just clicks into place. So, if 0.999 repeating is literally just another way of writing the number 1, we can just swap it out. Our kind of messy-looking equation, 3x equals 0.999, suddenly becomes something much, much cleaner. It simplifies beautifully to just 3x equals 1. And from here, it's about as easy as it gets. To solve for x, you just divide both sides by 3. And there it is. We get x equals 1/3. Now, let's think back. What did we say x was at the very start? We said x was 0.333. So if x is 0.333 and x is also 1/3, then they have to be the exact same thing. Algebra doesn't lie. Okay, so that was the cold, hard logic. But maybe that felt a bit too abstract. No problem. Let's prove the exact same thing all over again, but this time, let's use something a lot more intuitive. Let's use chocolate. I want you to picture one single whole chocolate bar. This bar represents the number 1. It's one complete unit. Got it? Okay, now you're going to share it. So you carefully break that bar into 3 perfectly equal pieces. By definition, each of those pieces is 1/3 of the original bar. So, what is each piece in decimal form? Well, if the whole bar is 1 and you divide 1 by 3, you get 0.333. So you are literally holding 3 chunks of chocolate, and each one is a perfect physical representation of 0.333 repeating. So what happens when we put the bar back together? We take our 3 pieces, our 3 chunks of 0.333, and we add them up. And what do we get? We get 0.999. And what are we looking at? We're looking at our original complete single chocolate bar. The parts have perfectly reformed the whole. So there you have it. We've just walked down 2 completely different paths, one with pure logic, the other with a chocolate bar, and they both led us to the exact same conclusion. On the one hand, you've got the airtight algebraic proof. It shows that based on the rules of math, 0.333 must equal 1/3. And on the other hand, the chocolate bar shows us intuitively that those 3 decimal parts have to add back up to 1 whole. 2 different roads, same destination. And here's the real takeaway. A repeating decimal isn't some strange broken number that's just almost a fraction. It's just what a fraction like 1/3 looks like when we force it to be written in our base 10 decimal system. It's the same exact number, just wearing a different outfit. All right, now that you've seen how the magic works, it's time for you to try it yourself. Let's see if you can apply this logic to a slightly different but very similar problem. Here's your challenge. Take a look at the number 0.666 repeating. Using that same algebraic trick we just learned, what exact fraction is it? I'll give you a second to think about it. Did you get it? The answer is 2/3. If you follow the same steps, it works perfectly. You set x to 0.666. You multiply by 3, which gives you 3x equals 1.999. And hey, if 0.999 is exactly 1, then 1.999 has to be exactly 2. So 3x equals 2. Divide by 3, and you're left with x equals 2/3. It's the same elegant logic. And this is the big idea, really. A fraction like 1/3 and a decimal like 0.3333 are not an approximation and a reality. They are just two different languages for describing the precise same point on the number line. They're two sides of the very same mathematical coin. And that leaves us with one final fascinating thought. We've seen that decimals that repeat in a predictable pattern can always be written as a simple fraction. But what about those other decimals? The ones like pi that go on forever but never repeat in a pattern. What kind of numbers are those? Well, that is a question for another explainer. Thanks for tuning in.